All right, this one we're trying to find the area not of the full circle, but of what's called a sector of the circle, almost like a pizza slice. This is very similar to the circumference and the arc thing, where we were just trying to find this arc length. Now we're trying to find just this area, and it's treated in very much the same way. So as always, we know area equals pi r squared. That's going to come into play. And anytime you can find the area, it's usually a good idea to do so. So as soon as they give us the radius as 4, we can go ahead and say, okay, well, what is the area of the full circle? Pi times 4 squared, so it's 16 pi. So might as well just go ahead and start with that. So this full circle is 16 pi, but I don't care about the full circle, I just care about this area here. So what I need to know is what fraction of the circle this represents, because the formula for this is very similar to the arc equation. It's that the area of the sector equals the fraction of the circle we're talking about times the full area. And so I'm trying to find the area of the sector. I need to know what fraction I'm talking about. So it says this angle is 80 degrees. So it's 80, and again, we know a full circle is 360. So 80 out of 360 times 16 pi. And this is, again, exactly like the arc stuff. And now I just simplify. So what I can do is say, okay, 80 over 360, that's pretty much the same as 8 over 36 times 16 pi. And then I can say, okay, these are even numbers, so I can simplify that to 4 over 18 times 16 pi. I can say 4 over 18 is 2 over 9 times 16 pi. And then I can say, okay, I can't really simplify this any further, so 16 times 2 is 32 pi divided by 9. And so this right here, and this is in meters, so this will be meters squared as an area. This will be the area of this sector. So it's smaller. 16 pi is bigger than 32 pi over 9. So 32 pi over 9, it's roughly 30 over 10. It's roughly 3 pi. So it is, definitely a fraction of this area here. All right, so that's one way to do that problem. Let's go to here's a problem where we know the angle, this area they're telling us is 4 pi, and we know the radius, we want to find the angle. So once again, whenever you have the chance, it's usually good to find the area of the full circle. So area of the full circle is pi r squared. Hey, we have the radius, so it's just pi times 6 squared. So the full circle is 36 pi, and again, if we want meters squared as the unit. And we know, in this case, the area of the sector. We're looking for the angle. So we set up our equation. We know that the area of a sector equals the fraction of the area of the circle times the full area. So what can we fill in? The sector's area is 4 pi, and we don't know the fraction at the moment, so we're going to leave that as fraction, and the area of the full circle is 36 pi. So I'm going to start by trying to solve for the fraction. So what I can do is multiply both sides by 1 over 36 pi. It's equivalent to dividing by 36 pi. So when I do that, I get 4 pi over 36 pi equals the fraction, because this cancels. Pi's cancel. 4 over 36, if we do out our math, is 1 over 9. So the fraction of the circle in question is 1/9. Now what we're trying to do is find the angle. So we can say to ourselves, well, the full circle is 360. So 360 degrees times the fraction, 1/9, that is going to tell us this angle. So 360, and if you can't do this all in one go, that's fine. Maybe you don't want to divide 360 by 9, so you say, well, it's divisible by 3, so that would be 120 times 1 over 3, and then you might all of a sudden click, oh, this must be 40 degrees. So this angle then is 40 degrees. It's, a pretty small fraction of the whole circle. So this is almost identical to the circumference and arc. So it's just a slightly different equation that you're using area instead of circumference, but it's the same method, same treatment. So, if you're having trouble with this, maybe go back and make sure you understand that well, because they're more or less the same thing. But that's it. Until next time, I am Derek Genova. Have a delightful day.